Hello, and welcome back. We're next going to talk about what a sex-linked pedigree is going to look like. All right. Most sex-linked traits are going to travel as recessive traits. All right. And when we're talking about sex-linked traits, we're talking typically, the example I'm going to give is going to be something that travels on the X chromosome. You can also have things on the Y. The Y is a very small chromosome, doesn't tend to have a lot of genes associated with it, so it's not quite as common to have something that's going to be Y-linked. But sex linkage is going to follow on the X chromosome, okay? An example of a trait that is sex-linked is going to be red-green color blindness, okay? So there's going to be a bit of difference in the nomenclature and how we're going to represent this. Because it travels on the X chromosome, with sex-linked traits, we're going to put an X in here, okay? And a capital B, because we're going to use the B for blindness. Is going to give us normal vision. All right? If we've got an X and a little b, we're going to be colorblind, or the individual is going to be colorblind. Okay? Now, in terms of X and Y chromosomes then, females are going to have two X chromosomes. Oops. So in this case, we know mom is a carrier. So she has to have one normal copy and one mutated copy, okay? Because she's a carrier, all right? Dad is not colorblind, so the X chromosome he inherited from his mom has to be capital B, and then he inherited the Y chromosome from his father, all right? Now in their offspring, if you notice, none of the offspring are unaffected. And this is just to show you that with recessive traits, you can have them skip 1, 2, even more generations. But the way we would follow this then, okay, we know that this particular female had to inherit the mutant allele from her mom, the dominant or normal allele from her dad, okay, because she's a carrier. That's true also of this daughter. Okay, this son had to have inherited the normal X chromosome from his mom because he got the Y chromosome from his dad. Okay, that's true also for this male. Okay, so we can figure out their genotypes. The affected, or the carrier, daughter that's a carrier marries a man who is not colorblind. Okay. But they have sons that are colorblind, all right? The only way their sons would end up being colorblind is if they inherited the mutant allele from mom and they got the Y from their dad, okay? In this case, this daughter is unaffected. She got this allele from dad, and we know she had to have gotten this allele from mom, okay? One of the things with sex-linked traits, you are going to typically see it's going to be males in the pedigree that are going to be affected. If you notice in this pedigree, all of the affected individuals are male. That's something that's typical in traits that are sex-linked, okay? So if we finish filling in our pedigree here, this daughter had to have gotten the normal allele from dad, or I'm sorry, she comes from another parentage. So because she's a carrier, she's got one normal, one mutant allele, all right? This son is not colorblind, so he had to have gotten the X from his mom, he got the Y from his dad. This daughter is a carrier. She got an X from her dad, and she got the mutant allele from her mom, okay? marries a man who is not colorblind, okay? And again, they have an affected son. So that son had to inherit that X chromosome from mom because he got the Y chromosome from dad, all right? This daughter, again, got both normal alleles from parents, all right? So this is going to be an example kind of a sex-linked pedigree. Again, you can figure out what the genotypes, and we're talking about genotypes, that's when I put in the X and the Y, all right? Know that when we're talking about a sex-linked trait, how we track it is different, okay? I didn't just use big B, little b, okay? If I use just big B, little b, that would be indicative of something that would be autosomal, not sex-linked, okay? So you've got the X to show that the mutation is traveling on the X chromosome, all right? I guess I should fill in here, because we've also got the Y chromosome. That's going to go along with being male, all right? Again, all right, there's a little difference in the nomenclature and how we write it. Don't let that mess you up. It's recessive, so you can get generations that get skipped. I should write in my normal Roman numerals for you here. This would be generation 1, generation 2, generation 3, and then down here we have generation 4. Okay. If you have any questions about that, please let me know.